Welcome back, folks. We are going to get to our final video for this unit, and we are going to dive into pedigrees. And pedigrees is the way that we show how certain traits and alleles and characteristics are inherited from parents to offspring. And we show that over a long period of time. Think almost like a family tree. And based on the information in this family tree, we can determine what types of traits are inherited and how they're passed on from one generation to the next. So by the end of this video, you should be able to understand the purpose of a pedigree and how it's built, as well as analyze pedigrees for the inheritance patterns that are present. So two things we're going to look at here. First is the term carrier, and the second is pedigree. So when we look at a pedigree itself is a chart that's used to show familial relationships, and if an individual has a certain type of trait. Now, we have a certain key that helps us understand what these pedigrees look like. The circles are girls, and the squares are boys. Now, depending on how they're shaded in, and the pattern in which they're shaded in, that helps us determine if a trait is dominant or recessive, or if it is autosomal or X-linked, so if it's an X-linked trait or not. So we'll take a look and understand how we evaluate those. But if we take a look here, for example, if we look on the far right-hand side, look at generation 3, Roman numeral 3, so the third one down. And all the way on the right-hand side, we have 10 and 11. 10 and 11 are parents of 5, 6, 7, and 8 below that. So 10 and 11, boy and a girl, had 4 girls, all of which did not have the trait. 10 has a sister, which is number 9. And those are the offspring of 6 and 7. So you can kind of see and understand family trends as we go through and look at pedigrees. So lines directly across from one another indicate marriage. So generation 1, 1 and 2 at the top, those two individuals are married. There's a line that directly connects them. A line down indicates offspring. So 1 and 2 at the top had individuals 2 and 3, so they had 2 offspring. If an individual is shaded, they're affected with whatever type of genetic disorder you're looking at. If they're unaffected, they're not shaded in. Now, sometimes if we know that an individual is a carrier, sometimes they will be half shaded in, but don't expect this when we look at pedigrees. So how do we know what types of traits exist, and how can we determine that? Well, the first thing you want to look at is this a trait that is dominant, or is this a trait that is recessive? And the way we look at this is through two ways. It has to be a dominant trait if two parents that have the disease have an offspring that does not. If it were recessive, they'd have 4 little a's or 4 little letters, which meaning that all the offspring would have that disease. But because it's a dominant trait, one of the individuals or 2 of the individuals must be heterozygous. Therefore, that is how you end up with 2 that are shaded in that are parents and 2 offspring that do not have the disorder. So you need to look for that in a pedigree in order to determine if it is inherited, if it is a dominant allele. If it's a recessive allele, 2 parents that don't have the disease will have an offspring that does. That's because the recessive allele is masked by the dominant. So for example, here on the right, you see that 1 and 2 do not have the disorder, but have an offspring number 4 that does have the disorder. That tells you that parents 1 and 2 must be heterozygous for the disorder, and number 4 has the disorder. So we look for this in our pedigrees. If it's dominant, we'll have 2 parents that have it, that has an offspring that does not. And if it's recessive, we'll have 2 parents that don't have it, that have an offspring that does. So how do we determine if it's X-linked or autosomal? Well, because this is an introductory biology class, we're going to make it pretty straightforward here. We just need to look at the number of males and females that are afflicted with the disorder. In this instance, if it is X-linked, more males are going to be impacted than females, particularly if it's recessive. If it's dominant, that's a whole other story. We won't go into that. But if it's X-linked, it's going to impact males much more often than females. If it's autosomal, it should impact males and females equally. So as you can see, the one at the top is going to be X-linked and recessive, while the one at the bottom here is going to be autosomal, and it could be dominant or recessive. Odds are it looks like it's probably, I take it back, it has to be recessive because we look at individuals 8 and 9 in the second row have an offspring that does have it, number 17 in the third row. So that's going to be autosomal recessive. So keep in mind, we can look at the number of afflicted males and females, and that helps us determine if it's X-linked or autosomal. So use these keys, use these ideas to help analyze pedigrees, because pedigrees are a great way to show how traits are inherited over many generations. That's the key word for the video, generations, so make sure you write that down in your video notes. Analyzing pedigrees for inheritable traits depends on how they're passed down through the family. Patterns can be easily recognized for how the trait is inherited. So hopefully you got a good idea for this, a little bit shorter video this time around. When we talk next time, we will probably dive into evolution. So we'll talk to you then, guys. Have a great day, guys. Bye-bye.